Squaring a binomial. We begin with multiplying two arbitrary binomials. So I may have something like x plus y, and another binomial could be a plus b. Now, most students know how to multiply these two binomials. They call it the FOIL method, but really it's applying the distributive property twice. So you multiply each of these terms here with each of these. You multiply x times a and then plus x times b, and then you multiply y times a plus y times b. And for arbitrary binomials, that's all you can do. Now, these are all unlike terms. No two of them can be combined. Now we will talk about what happens if I replace this a plus b with x plus y. So if I have the same binomial, x plus y times x plus y. Now this is actually, it could be written as x plus y quantity square. So when you multiply two of the same quantities, you say that you are squaring that. Now notice, if I try to expand this as I have done here, I multiply x times x, which is x square. If I multiply x times x, I get x square. And then x times y is just xy. Now I move on to this y in the first factor. Y times x is yx. And y times y is y square. So unlike here in the general case, I actually have two terms that could be combined because x times y is the same as y times x. So I can write this as x square plus 2xy plus y square. So one common mistake that I have found is for students to think x plus y quantity square is just x square plus y square. It's not. That's a very common mistake. So let me write this down. X plus y quantity square is not x square plus y square. What is it? We just found out. So it was x plus y quantity square here. We multiplied them. We wrote them as two separate binomials, expanded and then combined like terms, and what we found was that it not just had x square and y square, but it had a middle term of 2xy. So let me write that and put it in a box. So this is x square plus 2xy plus y square. Now this formula is worth remembering for several reasons. The first reason is, if you know this, then you know that it's not just x square plus y square. So you would avoid that common mistake. And there are other reasons for why you want to know this. Now, one other way to see this is to use a picture. So what I'm going to do is I'm going to draw a square, and I will mark some points on the two dimensions of the square. So say from here to here it's x. X is all of this distance. And same thing, I will mark a distance x on the lower side. And then these two shorter segments, let me call them y. So what do I notice? I notice that I have a square whose side length is x plus y. So it's x plus y in this direction, x plus y in this direction. So the area of this square is simply you multiply these two, so you get x plus y quantity square. And notice, if I were to just add x square and y square, then this is what it's going to look like. This is x square because it's x times x. Now, what is y square? Y square is this top right corner. Y square. So bottom left corner is x square, top right corner is y square. But this square actually has not just these two pieces, but it also has these two rectangles. Now this rectangle has dimensions y and x, so this is xy. And so does this rectangle. This has dimensions x and y, so this is xy again. So as you can see, x plus y quantity square is actually x square plus both of these rectangles is 2xy plus y square. So the purpose of all this explanation is to make sure that we don't forget this formula. X plus y quantity square is x square plus 2xy plus y square. Now let's also look at x minus y quantity square. So if I have to square x minus y, then I write the same way, x minus y times x minus y, and then FOIL. X times x is x square, but this time there is a negative sign, so I got to be careful. This is x times negative y, that's negative xy. And now I have negative y times x, that's negative yx. And then I have negative y times negative y. Negative times negative is positive, so I get positive y square. And again, I can combine these two middle terms and I get, because xy and yx are the same, I have negative xy, negative xy, that's negative 2xy. I have two of those xy's plus y square. So what's my formula now? It's x minus y quantity square equal to x square minus 2xy plus y square. And as you can see, you simply can't distribute that x square minus y square. You can't say this is x square minus y square. No. It has three terms. Again, it's x square minus 2xy plus y square. So this is also important to remember. Let's go back to the earlier formula, x plus y quantity square. There it was x square plus 2xy plus y square. Now if you have x minus y quantity square, it looks very much like what we had, except the middle term comes with a negative coefficient. So it's going to be x square minus 2xy plus y square. Now typically in problems, what you may have to do over and over again is there will be very unlikely that you have two variables. This is going to be a number. So say x plus 1 quantity square or x minus some number quantity square. So let's do some examples that are of practical significance. So I'm going to have x plus, not y, let's say 6. Usually in problems, you have only one variable, x, and then the other is a number. So how are you going to expand this? Well, it's going to be x square. Now you remember it was 2xy, which means you multiply these two, which is 6x, but you have to double it. So it's going to be 12x plus 6 square is 36. All right, let's do one with a negative sign. So say x minus 10 quantity square. Now we can see it here. The first and last terms are going to be easy. X square. If you have a minus, then you'll have a minus here in the second term. And what would it be? It would be double their product. So I need to multiply, or I basically double this 10 and I get 20, and I will have that x. Plus, now 10 square is 100. So notice, whenever you have a variable and a number here, the middle coefficient is going to be double of what you are going to see inside the parentheses. So maybe we can try one more, x minus 9 quantity square this time. It's x square. If I double 9, I get 18x. So if I have a minus, the second term will be minus. But it would always be 9 square is 81. The first and the third terms, they are always going to be pluses because they are squares. And whenever you square something, it turns into positive, right? Awesome. M minus 1 quantity square. So this time it's m square minus 2m plus 1. So you get the idea. Whenever you have to expand or whenever you have to square a binomial, you're going to have three terms. The first term is the square of the first. The middle term is twice the product. If you have a plus, you would have a plus here in this second term. If you have a minus, you would have minus in the second term. But it would be twice the product. And the last term would be square of the last term. So 6 square is 36, 10 square is 100, 9 square is 81. 1 square is 1. 1 times 1 is 1. So that's all I have in this video. And I made some practice problems. And you can find the answers to that in the video description. So there are 8 problems. And what I'm asking you to do is expand by squaring the given binomial. Meaning you just have to apply the formula. And once you have done these problems, you'll have a pretty good idea and things will speed up for you in future. All right, thank you very much, and I'll see you in the next video.